The remainder of these live lessons are dedicated to the exciting topic of deep reinforcement learning. Throughout this part of the live lessons, we're going to be focusing on a specific game that we're going to be training our deep reinforcement learning algorithms to play. It's a super simple game. It was invented in the 80s out of Richard Sutton's group at the University of Alberta. And it's called the Cartpole game. So the Cartpole game is really simple. It involves this cart moving in one dimension back and forth on this line. And this cart is supporting a pole. They're connected at this blue dot. I'll show it in action in a moment. But the idea here, the way that you win the Cartpole game, is by balancing the pole on top of the cart so that it doesn't fall down. The target number of frames in version 0 of the Cartpole game, which we'll be playing, is to keep that pole up for 195 frames of the game. So there's two ways that the game can end. The first way is by keeping the pole up for 195 frames, for 195 time steps. The other way that it ends is if you die. And the way that you die is by having the pole fall off. So there are 4 pieces of information. The reason why we use the Cartpole game as our game for training our deep reinforcement learning agents is that the number of states in the environment is very small. There's only 4 pieces of information that you need to get from the environment. There's the position of the cart, so where on this one-dimensional axis is the cart, or what's its position? What's its velocity? So how quickly is the Cartpole moving, left or right? What is the angle of the pole? And what is the velocity, the angular velocity of the pole? So the more that the pole starts to develop an angle or angular velocity, the more likely it is that you'll lose the game, and the harder it is for the cart to stay under it. So the name of the game is just kind of balancing. You can also, if you end up tipping off the screen one way or the other, that's another way you can die too. So you kind of you need to keep the pole centered and balanced nicely there on the cart. There's only 2 actions that our agent can take in this game. That's to move the cart to the left or to the right. So a 0 or a 1 is the 2 possible different actions. Let us have a look at this guy in action. So I'm just going to run the DQN notebook that we're going to build over the course of this lesson. I just want to show you guys how this works. So here is the game in action. So you've got the pole, and this is just playing game after game back to back. So it's kind of difficult to tell where one game ends and the next one begins, but essentially anytime the pole starts to fall, the game just stops and we're starting again with a new episode of the game. So each of these episodes provides an opportunity for the pole to train. And we can see here even early on, it's actually training from scratch. We can see already after only a few dozen trials, it's starting to every once in a while manage to keep the pole upright. Okay, so that's our goal. That's our goal. That's what we're trying to get to over the course of this lesson. Now we have a lot of steps to get there. Let's first have a look at the OpenAI Gym website. So the OpenAI Gym is the source of this environment interface for our agents. So the OpenAI Gym provides a bunch of different environments you can explore. All of them are more complex than the Cartpole game, but so we're just going to start with the Cartpole game today. Many of them are really complex, like Atari games, where the environment state is all of the pixels on the video game screen. So obviously that's a lot more complex to train up an algorithm to perform well than just having these 4 states of the environment that we need to keep track of. So as it states here, the episode ends when the pole is more than 15 degrees from vertical, or if it moves more than 2.4 units from the center. So that's going off the screen. And you win the game, you solve the game by getting an average reward, so managing to keep the pole upright for 195 frames on average over 100 consecutive trials. So you can see people's algorithms for playing this game. So some people have solved it it took 85 episodes for the algorithm to become proficient at this task and be able to solve the game. Andrej Karpathy, who is a very famous deep learning researcher, he, 2 years ago, it took him 211 episodes to average above 195. And you can actually go click through and look at his or anybody else's algorithm, their agent, for playing the game. So here's a look at an agent. We're going to be making a simpler version of an agent today. But this is a fun way that you can explore how various other people have set benchmarks and the differences between their algorithms. So that's the Cartpole game. Now we're going to dive into some theory so that we can figure out how to build our own agent for winning the Cartpole game ourselves. Let's get into that.